Hello, everyone, and welcome to another edition of the Science Friday live stream. I am Diana. I'm the Experiences Manager for Science Friday, and I'm joining you from kind of windy and a little cloudy Brooklyn, New York tonight. Thank you again so much, everyone, for joining us, no matter where you are joining us from. Speaking of which, if you have not already gone to the chat and let us know, you can let us know where you're joining us from. We have people, let's see, from San Francisco, California, San Diego, California, Montevallo, Alabama, Jacksonville, Florida, New Mexico, Michigan, Pennsylvania, Honolulu, Hawaii. Amazing. Keep letting us know where you are from. We're so excited to have you. And if you want to chat with us, make sure you log in to YouTube. That is the easiest way to actually be able to join the chat. If you don't know us, we like to say that Science Friday is your one-stop shop for all things science news. We are well known for our weekly science radio show, broadcast every week on, you guessed it, Friday from 2 to 4 p.m. Eastern on your local radio station. You can do that every week, or you can go on our website, sciencefriday.com. You can click the listen banner that appears at the top of the page while we are broadcasting the show. Today, though, we are doing something a little bit different. We are gathering with the author of this month's read, which is a nonfiction book about hope, stories, and life amongst the stars, titled The Possibility of Life, Science, Imagination, and Our Quest for Kinship in the Cosmos by science writer and first-time author Jaime Green. And if you want to join fellow readers to discuss the book picks together, you can do that on our book club community. So I'm going to post how you can join in the chat right now. So you can go to sciencefriday.com/book club literally anytime to find out more about all the things that we are doing. All right, a kind reminder before we get really started with our author tonight. Science Friday is committed to providing a welcoming and harassment-free environment for members of all ethnicities, ages, gender and trans statuses, sexual orientations, physical abilities, national origin, beliefs, and any other dimension of diversity. We've created a code of conduct, which you can actually find and read in its entirety on our community space to help us create a safe and positive community experience for all, and believe that providing clear expectations is a necessary part of building a respectful community. So here are the basics. Be supportive and respectful when speaking with one another or asking questions in the comments. Share generously and listen closely, and you can add your thoughts throughout, even if they aren't strictly questions for our guests in the chat. Do your best to stay on topic, as we're here to discuss this month's book pick, which again is called The Possibility of Life, and related topics. And we reserve the right to ban anyone who engages in demeaning, discriminatory, or harassing behavior in the chat tonight. So keep that in mind. All right, that's all I've got for you. But thanks for sticking with me. With that, it is time to welcome our special guest to the stage. So please welcome Jaime Green. She is a science writer and the author of The Possibility of Life, Science, Imagination, and Our Quest for Kinship in the Cosmos, which is the Science Friday Book Club pick for this month, and she is based in Connecticut. Welcome, Jaime.
Hi, thanks so much for having me. Hello, everyone.
Yeah, thanks so much for being here tonight. I'm so excited to just get a chance to talk to you. So let's just dive right in.
Yeah.
So our readers are really loving this book so far, and I could talk forever about what it is that you do and what the book is about, of course, but I can, not do as good of a job as you can, because I'm sure you're talking about the book a lot. So tell us a little bit, just in your own words, about what this book is.
Yeah. So the short version is that this book is about how we imagine alien life in science and in science fiction, and then looking at what all of those imaginings tell us about what it means to be human. It took me many years, but I finally got my elevator pitch down. The slightly longer, less polished within an inch of its life version is that this is a nonfiction book. I think of it as a work of creative nonfiction that, puts science and science fiction together to see what that reveals. And so I cover a bunch of big questions that are wrapped up in the question of what might life on another world be like. Everything from how does life begin to what we know about planets, because if you're going to have life, you got to have somewhere for it to be, to evolution, what makes a person, like what makes an alien or another being a person, because it's more than just intelligence, and then technology and contact, like both the Carl Sagan book and the act of making contact. And in each of those very big buckets of a chapter, I look at different ways that we imagine answers to these questions in science, through conversations with scientists, talking about their research, and then also looking at examples from sci-fi, TV, books, movies that have imagined possible answers to these questions.
Awesome. This is your first book, although you have written articles and a lot of other science writings in your past. What was it about this topic, this idea of how we talk about life on other planets, the possibility of life on other planets, and what it says about us and our history of trying to answer that question? What was it about that question that made you want to write a book?
It's been something that I've loved my whole life. You know, I grew up on Star Trek. I, before even thinking about writing this, already had a tattoo from part of the Voyager Golden Record on my leg. Like, I've just always loved this. But it wasn't until I got to graduate school, and, you know, I said creative nonfiction. I have a master's degree in creative writing and nonfiction writing, lest anyone thinks that I'm an astrophysicist.
You're just very good at asking the
I just feel like it's very
questions.
Right. I'm good at asking questions, not as good at calculus, which was
Same.
When my path diverged. But yeah, I was in grad school and realized that I've always loved science and I've always loved writing. And why was I not, like, duh? It was like, how have I not thought of this before, to write about science? And then everyone in the program had to do a semester-long class on research and pick a topic to research. And I wanted to write about the Voyager Golden Record, and my professor said, go bigger, just write about aliens. And I was like, well, that is a lot bigger, as you see from the scope of the book. Like, it's a short book, but it covers a lot. And but the problem was that, you know, I loved writing that project that semester, and I was like, ooh, I want to write a book about this. And then I would go to the bookstore and do the thing that a lot of writers do, where I would visit the shelf where my book's future home would be. And there were already books on this topic on the shelf, and they were all written by scientists. And they were all looking at, you know, how do we study? How do we search? Like, what are the odds? Is it likely? Is it not? How are we going to find it? That sort of stuff. They're really just practical. They were science books. And it wasn't until a few years later that I realized that what was actually more interesting to me was not looking at it as just a scientific question, but I love it because it's also a cultural question. I didn't get a tattoo because I love the science. I got a tattoo about it because I love what it means. I love the romance. I love the imagining and the hope. And so I realized that bringing in science fiction was a way of looking at that project from more angles, looking at it as how we imagine answers to these questions, how we try to understand our place in the cosmos. That's just as much happening in science fiction as it is through science. And so that just sort of opened it up for me and helped me figure out what my version, what my contribution, what my place on that little bookshelf was.
Yeah. Did you find yourself, I find when I think about my contribution to these kinds of discussions, it's just so intimidating. Did you find yourself having to just kind of hype yourself up of I have a different story to tell. I'm very excited about this. I think people will really enjoy this book. Or are you just I got this?
I never really had doubt about the book's place in the world. And I'll admit, when I was trying to sell this book, a lot of the feedback that I got from editors, or that my agent got from editors and then shared with me, was people being I don't see how this comes together as a book. I don't see how this is a book. And I always knew that they weren't getting it, that there was, I was like, no, this is a book. It makes sense. It always made sense in my head. The thing I had to hype myself up about was, as a writer, not me versus the scientists, but me in context of science journalists. Because I don't think of myself as a journalist. I think of myself as an essayist, and it's a different approach. It's working with different models, different sort of structures, because it's a different genre. And so one of the mantras that I would repeat to myself, at the beginning of my workday when I was sort of getting in the zone, was, I am an essayist. That I don't need to follow the structures of science journalism. The book doesn't need to read like science journalism. And my role in the book as the writer and narrator and the character is a little different. That I'm also an outsider. I'm with the reader being excited about this, and I'm excited to share what I've found. And it also just like gave me permission to follow, you know, any of my weird little larks as I was writing and just like write it as myself rather than trying to like, I am a journalist, I am serious science person. And not that science journalists don't find ways to be fun and creative and delightful, but it was like what I had to tell myself in order to keep working the book. Like that's where my imposter syndrome crept in, was about like my track record as a writer rather than my grasp of the science.
Interesting. Yeah. Well, we've been sort of circling around the book, but let's just like kind of dive
Yeah.
into it. So you start by kind of giving us like a one-on-one lesson, 101 lesson about our ideas about life. So it's origins, its histories, definitions, our theories. And you mentioned that NASA's working definition of life is a self-sustaining chemical system capable of Darwinian evolution. I asked our community what they thought of this definition, and they don't love it, and they had a lot of really interesting ideas. But what do you think about that definition? What do you think? Do you think it works, or is it missing the mark?
I It's interesting. Like I touch on this a little in the book, but something I've been writing about since the book, like recently, that I'm working on a piece about now, actually, is it's not just that the definition isn't a good definition. It's that defining life is a misguided project.
Mm-hmm.
Because definitions tell us what words mean, and we don't need to know what the word life means. We need to know what life is, because if we're trying to recognize it on another planet or understand how it began and recreate those origins in the lab, we need to know fundamentally, like to understand this aspect of the universe, right?
Mm-hmm.
And the way that we do that in science is not with definitions, it's with theories. Like saying gravity is the force that holds me to the earth doesn't help me understand gravity at all. We understand gravity like through the work of Newton and Einstein, that, force equals mass times velocity. Like that is a theoretical encapsulation of how force exists. And Einstein then building on Newton and, hundreds of years since, saying that gravity is the curvature of space-time. That's not defining gravity. That is understanding something fundamental about how the universe works. And we have a lot of a theoretical understanding of physics. We have theoretical understandings of chemistry, like with water. Defining water as like a drinkable liquid is not a scientific understanding. Saying water is H2O requires seeing invisible things to understand. Plate tectonics was a theoretical understanding that
Yeah.
explained so many different kinds of observations and allowed us to make new predictions and test them with evidence. We have none of that for life. And so there's not going to be a definition that works because it's not a dictionary. So, and I do think that including Darwinian evolution is really tricky if you're trying to use the definition to make sense of something you're observing. You can't sit and watch microbes on Mars, see if they're evolving, right? Like we need something that works a little more quickly. But but this is really tricky because we build theories out of observations, out of evidence making sense and sort of finding a framework that everything fits into. And we only have one example of life, and that's life on Earth. And we don't know if it is weird or normal. We don't know what things we observe about life on Earth are fundamental to life or just like how life is. Like if I'm trying to come up with a theoretical understanding of a chair and I only have the chair that I'm sitting on, it's like, well, are chairs black? Do chairs have wheels? Do chairs have a seat? There's no way to know what's fundamental and what's just that version. So I could go on for a long time. I'm obviously like really jazzed about this because it's what I'm writing about now. But yeah, they're just totally off the mark.
Yeah. It's good to know.
Sorry,
All right.
NASA.
We'll let NASA know. I wonder then if you think perhaps that we've encountered life, but we just haven't been able to see or understand that it is what it is.
Yeah, there are two possibilities where I think so. One interesting idea is the idea of a shadow biosphere on Earth. That's a term that comes from the philosopher Carol Cleland,
You
who
could,
also
yeah, write a whole book,
I
Shadow
know, isn't that
Biosphere. So good.
such a cool word, the shadow
Yeah,
biosphere.
I love
And
that.
Carol Cleland is also like I should credit her as the thinker who's like framed a lot of this with the problems of definitions and
Hmm.
how we think about a theory of life. But a shadow biosphere would be so all life on Earth shares a common origin and
Hmm.
shares common chemistry, same building blocks. It's entirely possible that life arose on Earth more than once, and it's entirely possible that not all of those other origins died out.
Hmm.
So there could be, it's obviously not large scale, right? It's not
Hmm.
walking around, it's not swimming in the ocean, and it's not macro scale. But
Hmm.
there could be microbial life on Earth that's not related to the dominant biosphere that we can't detect because its chemistry is different. Because all of our life detection methods for, chemical analysis and whatever rely on things like RNA, which is I think universal, but would not be shared by the
Hmm.
shadow biosphere. So it could be there and we don't know it. The other example is there's only been one time that we've actually done experiments on Mars looking for life. The Viking lander in the mid 70s had a little life detection mobile lab and it
Hmm.
like did some sampling. Everything since then has been assessing habitability, looking for proof of water. Nothing was looking just for life.
Hmm.
And that experiment, that set of experiments, is really proof of the danger of narrow definitions of life and narrow expectations building off of just one example of life
Hmm.
because the results were weird. They like put nutrients into the soil to see if there was chemical evidence of someone gobbling up the nutrients, and at
Hmm.
first there was, and then they did the next phase and then like the results for the second phase didn't match the expectations of life, but something weird happened.
Hmm.
And the like official word was not, ooh, that's weird, let's go learn more, but was it didn't match our predictions exactly, so it wasn't life.
Hmm. Hmm. Okay. Or,
I think that there's just so much that we could learn from saying, okay, that gave us weird results, what other questions can we ask? And instead it was just a detour to other important questions, other easier questions. I would really, really love a Mars mission to go back and poke around in the
poke
dirt
around.
that way again. Yeah.
Yeah, I think that would be great. Yeah, maybe in our lifetime we'll see another one do that. That would be very cool.
I'll add this to the list of memos I'm sending to NASA.
That would be great. Yeah, thank you so much.
Mhm, mhm.
We've got some great
Okay.
questions from the audience so far, and I love this one because it also gets back to kind of so your book is I don't want to say it's half science fiction
Yeah.
and culture, but you weave together a lot of these ideas. And Sheldon asks, how did you choose or narrow down the science fiction books, also TV and movies, that you used as references throughout the book? 'Cause
The
there's a
science,
lot, but I'm
yeah,
sure you could have written more.
totally. And that's also the case for the science. Like each
Yeah.
chapter that I wrote could have been a whole book unto itself, but it was important to me to have them all together, and see what it adds up to. Um, the sci-fi that I write about was a mix of things that I had already known and loved, like Star Trek, The Sparrow, um, The Fifth Season, Semiosis. Like a lot of them were books that I came in loving and knew that they were like part of the inspiration for writing the book. Like
Mhm.
I knew that Semiosis, which is this amazing Sue Burke novel about a sentient plant, alien basically, like had to be a big part of the chapter on people because it's just such an amazing way to imagine a really alien kind of person, so rooted in science, and the challenge of recognizing that alienness. And like I knew Arrival and Story of Your Life, which is the short story that it's based on, like those that coming in with that knowledge helped me imagine the book. But then there were lots of gaps to fill, and I just did a lot of reading and a lot of I don't think that I watched any new movies now that I think about it, but finding new episodes of Star Trek to watch, new old episodes. But I did a lot of reading looking for, an interesting way of imagining life on a planet that's very different from Earth, or books that have interesting examples of very alien aliens, or examples of life. I just sort of, and it was a lot of asking around. It was a lot of lurking on the sci-fi subreddit on Reddit. I found this amazing post. People would just be like, what are some good books with very non-human alien aliens? Are there any books about aliens without humans? And I was just like, reading list. And it was really important to me that I only include books that I really loved. There are a couple examples. I write about Avatar. I don't love Avatar as a movie. I write about Solaris, and there are some parts of it I love, but the gender politics of that book are very mid-century. But I still loved things about it so much that I had to include it. Everything else, I wanted it to all be books that I felt enthusiastic about, because people have also been telling me that they're creating a reading list from the book, that it's introducing them to new sci-fi to read, which I'm really excited about. And so I hoped that would happen. So another way to narrow it down was not just, is this an interesting way of imagining the science, but do I love this book? Do I want to, it sort of feels like getting a tattoo, like immortalizing that book in my book. So that was important to me.
Yeah. By the way, on our community space, if you join, I someone requested, is there a list of all of the books and TV shows and movies? And I was like, I can do that. And I just made a little list, and so that's actually going to be publishing later this week. And so,
could you send that to me also?
I absolutely could.
There's a bibliography, but that also includes all the science and everything. And I've never actually looked at the list.
Yeah, I got
by
you.
itself. Okay, that would be awesome.
Yeah.
Can I choose a question to answer?
Of course you can. Go for it.
Because I just saw Francis ask this amazing question. Did you base each chapter on a term in the Drake equation? And I'll explain this, but I will just say not intentionally. So the Drake equation, which I get into in the introduction of my book, is sort of one of the foundational ways of thinking about SETI, the search for extraterrestrial intelligence. And it's but it's not an equation that's meant to be solved. Frank Drake, who is one of the fathers of SETI, one of the pioneers of SETI, wrote it on a whiteboard as an agenda setting exercise for a very early SETI meeting in 1960 or 61. And it was a way of saying, if we want to know if it's worth looking for signals, we need to know, is it likely that anyone's out there? And so what are the factors that would tell us how many other civilizations in the galaxy might be transmitting signals right now that we could detect? So what you do is you multiply, and I don't have my book open, so let's see if I have it memorized. Probably not. It's things like the rate of star formation, the fraction of stars that have planets, the fraction of planets that are habitable, the fraction of those planets on which life arises, the fraction of life that develops intelligence. I think there's a separate term for developing technology. And then you multiply all that by the lifespan of a civilization, not how long before it falls apart, but how long is it transmitting? They might go radio quiet for a lot of reasons. I think I got all the factors.
But it starts to feel like this.
Right, exactly, because almost all of those are fractions. And when you multiply a number by a fraction, it gets smaller and smaller. Most of those, especially the second half of the equation, we don't know the answer to. When Drake came up with the equation, we knew the rate of star formation in the galaxy, but we had no idea how common planets were. Now we know that planets are extremely common. Any star you point to in the sky, odds are it has at least one planet around it, which is, I just love knowing that. It really changes how you look at the night sky. So Drake equation, fundamental idea in SETI and talking about the search for life elsewhere. And you can see that there is a big resonance between that way of what are the factors we need to understand, and the way that I organize my book. What are the categories of questions that we need to ask? I didn't do it that way on purpose. I didn't have the Drake equation in mind when I organized the book, but it clearly was there as a way of thinking, because the structure of the book that way was there for me from the beginning. It was like how I figured out that I wanted to write this book was I knew that structure. And that clearly was the Drake equation talking to me in the back of my head. And the Drake equation, it only came into the introduction in like the second big draft. And then I was like, oh, that's where that came from. So very, very astute, Frances, because I didn't even realize it, but yes.
Those things have a way of sneaking in, especially when you're so entrenched in a subject matter. It's just like all of
it's
a
a way
sudden,
of thinking about it.
yeah, exactly. I find myself putting things into like forms of 8 when I'm talking about octopuses a lot during cephalopod week. So it feels like a little bit of a version like that.
Yeah, for sure.
We've got another question that I think a lot of people are generally kind of interested in now with the sort of rise of AI and machine learning craziness that's happening. But Matt asked, the neural networks of AI turn out to behave much like our organic brains, kind of. I mean, they're not as good at stuff as us, which I'm gonna knock on wood.
Yeah.
But does it suggest there is something essential about thinking that we would find with alien life? What do you think about that?
I love this question because it takes AI in like a new direction. Like, people have been asking a lot about AI. No one has asked this before. And but I don't think that it does, because neural networks on Earth are still creations of Earth life. And even though machine learning is a bit of a black box, it's still a creation of human hands. And so it is influenced by the human engineers who made it. And it's training on Earth data and human data. This is also a problem that comes up in the study of the origin of life, that one of the sort of general ways that those experiments work is you take some substances that you think were present in a particular environment on the early Earth in conditions, and you sort of try to see like, oh, can these two molecules sort of on their own have a reaction that leads to this next building block of life? But it's impossible to do that without getting life into it, because our intentions, how you purify the reagents, the choices that you make about which chemicals, like, it's coming from your understanding of chemistry. Like, it can't exist without that human touch. And I think that it's the same for AI. So we can't really, it's so hard to generalize from just one example. And I think that that's another case of that.
Yeah. Well, this actually leads me to one of my other questions too, which is about sort of like, if we do end up finding life on another planet or amongst stars, it seems like research is leaning towards that planet and that life having a very good chance of looking familiar to Earth like life. Do you think that's self-centered, or do you think that's good science?
I think that in terms of chemistry, I'm not talking about like walking around on 2 legs with 2 hands and a head on top,
Yeah.
right? But
Yeah.
in terms of chemistry, there are good reasons to think that water is a special substance, that carbon is a special substance. They do the things that life needs them to do exceptionally well. Like, it even comes down to just like what the atoms are like. But then I don't think that many scientists are saying, and we'll stick to microbial life because that's like what we're practically looking for. And the farther you want to go into complexity and evolution, the more paths are open and the weirder things can get, right? But in terms of simple life, I don't think it's that anyone is saying it's likely to be like life on Earth. It's just that's all we know how to look for. And also, when you're going to those common bits of chemistry, and then you think about like, what are the other things life needs to be able to do? Like, a cell needs a boundary. There needs to be an outside and an inside. I guess that even is being Earth-centric, though, because could there be some sort of like self-sustaining information-containing system that isn't cell? Yeah, I guess. Basically, the possibilities are so huge that we have to start somewhere. And so I think part of why scientists often talk about familiar forms of life is that's what we know how to look for. And
Mhm.
especially in the absence of a theory, a theoretical foundation that will say, here is every way that, like, here's what's fundamental to life. We're like, look, we know that life on Earth was really evolutionarily successful by doing photosynthesis and by using oxygen and whatever, and like figuring out how to energy and whatnot. And so it's about looking for the things that are more likely to be common and that we even know where to start.
Mhm. Yeah, yeah, I guess that's a good point. It's like, we were saying before, there's a good chance that we're, like, missing things amongst the planets, and the things that we will find will be the ones that we're looking for, and what we're
Yeah.
looking for is stuff that we see on Earth as well, or at least
Mhm.
chemically similar, so
Yeah.
makes a lot of sense. Um, Raymond has a really interesting question. They write, This is such a great topic to address by examining both the ideas of scientists and science fiction writers. I agree. Do you think this is because scientists know so little about what to expect from alien life? Do you think that's why? Or do you think that also maybe that science fiction writers are just like unbound by the actual realities and can kind of just do whatever they want?
I think it's both. And I think those are actually the same thing. That because scientists know so little about what to expect, they are in their work often reluctant to speculate. Their scientific questions
Hmm.
are, you are small reasonable steps. And
Hmm.
like I said, the farther you get from chemistry into biology, every step of evolution is so many branching paths that life takes. That goes this way, it goes that way. So the farther life goes, the harder it is to sort of predict what it would be.
Hmm.
So it's sometimes like pulling teeth to try to get a scientist to talk about what animals on another planet might be like, or how evolution might
Hmm.
work on another planet. And it's definitely not something that they're doing often in research papers, which is
Hmm.
one of the reasons that the book is built so much on interviews. Um, because I had to be like, what do you think? Just like, what do you think? Um, and so science fiction then is a place where that sort of speculation is what is being done. It's what's expected. It's what's required. It's still based in science.
Hmm.
Not all science fiction is, but the stuff that I was looking at, and it's, having a foundation in the science and then extrapolating rigorously and creatively.
Mm.
I also thought it was important to bring science and science fiction together because I'm not just saying that science fiction is an important part of this project in terms of its rigor, but
Mm.
also that science is an inherently imaginative project,
Mm.
that making a hypothesis is imagination, is creative, devising an experiment is creative. And I really think that they're entwined in so many ways.
Yeah, I love that. So you actually mention and center hope and optimism a lot in your book.
Mhm.
Why was that so important for you to do?
It wasn't intentional. I think it's what felt meaningful. And I think that it's
Mm.
it's a very common part of what we're looking for from life on other worlds, both
Mm.
in science and in stories, that the idea that there is life on other worlds feels hopeful. The idea that there are advanced aliens feels hopeful because we're very worried that we're about to kill ourselves off and have been since just before the beginning of SETI. Like SETI really started in 1959, 1960, very close on the heels of the atomic bomb.
Mhm.
And so there was the atomic bomb and nuclear war and climate change. And humanity is lately very good at figuring out ways to threaten our existence. But if we tell stories about advanced aliens who have made it much farther than we have, that's hopeful. If they
Mhm.
did it, so can we. Um, and maybe they did it by transcending a lot of the suffering on Earth. Star Trek, we don't spend a lot of time on Earth in Star Trek, but it is a post poverty, post war socialist world, on
Mhm.
Earth. And that is what opens up the possibility of all of that exploration and discovery and connection with other aliens as they've like figured things out at home. Um,
Mhm.
And hope is also what drew me to science fiction. Like Star Trek was the first sci-fi I got into, Next Generation. Around the same age, I was reading A Wrinkle in Time, which is a
Mm,
very humane, hope-driven, connection-driven kind of sci-fi. Like I didn't come to sci-fi for battles and laser guns, and there's none to very little of that in the book. Like
mm.
it's about connection. I think that's where the hopefulness comes too, where both in imagining what we might have with aliens that we discover or meet, and in the impact of that imagining on my relationship with life on Earth. It's about building connection, and that lives right next to hope.
Yeah, I love that. I never read A Wrinkle in Time, and I think it was one of those things where, like, right around the time when it was, like, perfect for me to read it, I was like, "I don't wanna read something that was written for someone my age. I wanna
Oh,
read adult books." And I feel very bad for my 11-year-old self now, and I think I need to go back and read it because it's come up in your book, it's coming up in a few other things I've been sort of reading over the last 2 years or so,
yeah.
and I think it's time.
It's very, very special to me. I did reread it recently, and it does read like a kid's book. You know,
Sure.
it like the action is like the some people show up, they say, we need to go on a mission to save your dad, and they're gone. You know, it's like very, very fast. It is a kid's
We don't
book.
need a preamble,
Um,
let's do it.
right, right. But yeah, those books are very, very influential. And like I start the book with Star Trek, and then the book
Mm,
ends with A Wind in the Door, which is the second book in that series, because like those are that's that's the thing, and it's so much hope.
yeah. I think a lot of people also probably felt like you were pulling at their heartstrings because a lot of people are fans of Star Trek in our community as well. And
Yeah.
so another show that I never got into, I'm very sorry to say out loud
What are
to
you
everyone
doing
here.
here?
I don't know. I watched Battlestar Galactica too many times. So Morgan has a great question. This kind of topic came up when we were talking a little bit in the community space about um, what what creatures do you think on Earth could, if we really truly understood sort of their experience of the world, could help us prepare for a meeting with an extraterrestrial, but also the definition of life. So we're coming back to that idea of like, what is life? Not just the definition, but like, what is it truly? So Morgan asks, this is a very Earth-based question, but what do you think about including geological formations in our definition of life?
I think that points to a real limit in our attempts to understand life, in that, you know, we think of life as we know it when we see it. I hold a rock, I hold a flower, I know what's up. Of
Mhm.
course, then you mention viruses and everything gets a little fuzzy.
Yeah.
But for the most part, we think that we don't have the scientific understanding yet. But just like I can feel gravity, even if I can't explain the science of it,
Mm,
life feels like the same thing. Our sense of that demarcation between what's alive and what's not, what's the product of life and what's not, is very cultural. There are
mm,
other cultures on Earth that would say that the wind is alive, that a river is alive, that there isn't a hard line, or that the line is different. I was talking to an anthropologist who studies, he's American, but he studies Japanese culture. And he pointed out that I think this is what he was saying. Apologies if I'm getting this wrong. That Japanese has two different verbs for, I think, to be.
mm.
And one is for animate objects and one is for inanimate objects. So a person gets one form, but a corpse gets another. And even though Japanese does also have a concept of aliveness in life, it shows that different cultures draw lines differently, you know, have different, or don't draw the lines at all. And so thinking about geological formations, like, to me, they are clearly not alive. They are beautiful. They are dynamic. They are part of Earth. They are active, but they are matter being acted upon by heat and motion, you know? Um, but I do think that it's important to look, if we're going to do science, we can't not do it within our cultural framework, but
Mhm.
it's important to be aware of them, and to remember that if I'm not NASA, I can explore, okay, what does it feel like? What does it mean to me if I think of geological formations as alive,
Hmm.
does that change how I feel about myself, about the trees outside my window? Does that change how I feel about the earth and my place in the cosmos? You know, like Carl Sagan's not going to come hunt you down for that. Um, so I
Hope not.
think, no, that would also challenge my understanding of life.
Yeah.
Passed away many years ago. But like the NASA police aren't coming for you. So I think, like, Morgan, what do you think about including geological formations in your definition of life? That's really what matters there.
Hmm. Yeah, I love that. We've got another question that I think kind of we're getting near the end of our time together, but I think this sort of ties us kind of heading in that direction. In general, Richard is interested in knowing the in the research community, do you think that there's enthusiasm for research of extraterrestrial life and SETI growing,
Yeah,
or is participation growing, or
I
is it
think
kind of
so. And I saw Richard ask this question while I was talking about the idea of a theory of life. So I
hmm
don't know if that might be what this was about. So I will, but the answer is yes to all of that.
hmm
SETI has been a really tricky field in that it suffers from what some people call the giggle factor, you know, looking for little green men. NASA and the federal government didn't fund it from like 1993 up until a couple of years ago. So
hmm
while SETI as a field has existed since about 1960, there has not been active research happening. And there's kind of like a missing generation where we have the founders of SETI, Frank Drake, Carl Sagan, Jill Tarter, and then the current generation. There's like a sort of, there's a big gap there.
hmm
But it is sort of coming, it's more respected, and also is
mm,
like taking the current generation of researchers are taking what I think they would call a more agnostic approach, where they're not like Carl Sagan talked a lot about what it would mean and how it would be a message. And like if you've read or seen Contact, that's really him saying, I think here's one way it could go, um, which has a lot to do with hope, and is a lot about like fulfilling our desires of
hmm
what we
hmm
want. Whereas the current generation is more just like looking for evidence of technology, not trying to talk to anyone, but just trying to find proof. They call it techno signatures, like
Yeah.
biosignatures. And I'm not saying this to disparage either approach. Like I said, golden record tattoo. Carl Sagan is like, you know, this book would not exist without his work. I wouldn't be writing about this if it weren't
hmm
for him.
hmm
But yeah, I think it is growing. Penn State um, has a very recently established SETI center. There's a lot of rigorous work coming out of Berkeley where it's just like people are getting their PhDs in SETI, which just didn't happen before.
Yeah.
And then, in case Richard was asking about theory of life, origin of life stuff, yes, also to that. Origin of life is another weird field where it's kind of siloed and weirdly competitive, where everyone has their pet theory, and it's been sort of antagonistic in the past. And there's a new generation of origin of life researchers who are like PhD students and postdocs now, like even younger than the SETI researchers I'm talking about, who are working in a much more collaborative, open-minded way. And with like collaboration between biologists, chemists, physicists are getting into it. So I think that's also a really exciting field.
Yeah, I wonder because it seems like there's this parallel trajectory between this idea of of research that SETI was doing and also research that people were doing about like magic mushrooms and those kinds of like psilocybin. A lot of that sort of like it happened a lot in the 50s, 60s, and then the 70s it was just like, nope, we're not doing that.
Everyone
Nobody
got
go
sort of
that.
embarrassed.
Everybody look in that direction, go somewhere else. And now with current generations, people are like, well, let's take another look. And I wonder what other fields of research are also going to follow a similar trajectory.
Yeah, that is really interesting. I hadn't thought about that before, but it's like weird stuff was happening in the 60s, and now it's coming back in a less kooky way. I don't think, which is again not to disparage, but like trying to make it legitimate rather than embracing the fact that it's this sort of outsider project, which I think is more
Yeah.
the case for hallucinogens than SETI, but
Oh yeah, there's definitely differences there,
yeah.
but I love that idea that there's like this kind of newfound excitement for both of those fields, and there's just
Yeah.
so much that we're going to probably learn in the next 10 or 20 years because of that excitement and vigor from these new scientists. So, um, unfortunately, Jamie, we're coming to the end, but I do want to ask you this last question.
Yeah.
So, people are really excited from your book, and thank you again for writing it because it was really just like, May's a hard month for me because it's allergy season, and
Oh
it feels
no.
like the earth wants me to just like be sick for like a month or two. And so it was really lovely to reopen your book and kind of get excited about what might be out there. But I'm wondering, so if people are really invested in this topic and they're looking forward to hearing more, what new studies or space
Ooh.
missions or just like stuff that you've kind of like got your ear out looking for, um, should they sort of keep an eye out for, or things that you're excited to sort of see the next phase on?
Yeah. I'm really excited about possible future NASA missions to Europa. I
Mm.
think that
It's a moon of Saturn
I have a
or
really hard
Jupiter.
time remembering the Saturn and I call them outer solar system moons because I cannot keep
Let's
them
go with
straight.
that.
And
I think
like
that's great.
there's a new count of Jupiter's moons. It's like 106 or something.
Oh, it's too
So
many. It's too many moons.
it is an outer solar system moon.
Love it.
I just was like, I can't. Um, and it has an ocean under a thick ice crust.
Hmm.
And
Hmm.
so there's a mission called the Europa Clipper, which is just such a beautiful, evocative name. Just an old ship going down to try to do some sampling.
Hmm.
And for anyone who's read my book or is going to, one of the sci-fi novels I write about, A Darkling Sea by James L. Cambias, is set in another solar system, a ice covered moon with a dark lightless ocean. It's just like a
Mm.
fascinating imagining of how life might evolve without any light. It's also a really fun book. It was one of the most fun books I read. It's like
Hmm.
a romp. So I'm really excited about that, and I'm really excited about work being done about this question of a theory of life. There's a set of researchers who I interview in the book for my chapter on the origin of life. Sarah Walker, who's a physicist, and Lee Cronin, who's a chemist, who are doing
Yeah.
some really cool work on this, like really out there work. And I saw someone ask like which scientist that I interviewed made the biggest impression on me. Sarah's definitely one of them. Her work is like very theoretical and
Hmm.
abstract, and she's amazing at talking about it. She has a book coming out in the next year or two that I'm really excited about too, because she's just a really great thinker and like wonderful to talk to. So those are the things that I'm especially excited about. And also JWST is starting to bring back observations of exoplanet spectra, which is a way
Hmm.
of detecting what substances are in the atmospheres of planets around other stars. You just had Sarah's website
I'm
ready to
very
go.
I'm very
That's
quick
amazing.
at Googling. So.
um,
But she's great. Yeah, I've researched her work before, and she's
yeah,
definitely someone to keep looking into.
yeah.
Sorry, keep going.
No, that's fine. That's fine. And so, yeah, look, whenever there's JWST news, if there's an exoplanet spectrum, that's really
Mm.
exciting. It looks way
Hmm.
less cool than pictures of galaxies, but the information is we have not been able to detect that before. So it's really exciting.
Yeah, I think you mentioned this briefly in your book about the project to sort of like turn data into sound data so we could actually like
Yeah.
hear the stars. We did a story about that on Science Friday as well, and it just like totally changed the way I thought about how we do this research and the different ways that we can interpret data. And it's just such a cool idea.
Yeah. Yeah. I love
Yeah.
that too.
Well, Jamie, thank you so much for joining us tonight. It has been just such a
Thank you.
romp, and we really loved reading your book. So thank you again, and we hope that you write another. No pressure, but if
No,
you do,
from your mouth to publisher's ears. I hope so
um,
too.
yeah. Well, thank you again. This was really, really insightful, and thank you all to our guests who are attendees who asked their really great questions. I write many questions for these talks, but they are never as good as our attendees' questions. So thank you for coming in for
Yeah.
asking them.
Thank you everyone so much. It like is very exciting to know that there are strangers who are excited about my book. I'm still in the
Yeah.
phase of publishing where that's like, people are here for this. That's amazing.
Yeah.
So
They read
I
it?
really
How?
appreciate. I know. I really appreciate it.
Yeah, well, thank you again. So the Science Friday Book Club, by the way, for everybody here, we are just about getting into Cephalopod Week, which happens in June. And so next month we are reading a book by Dana Stoff, but it's called Monarchs of the Sea. And so if you're interested in learning more about weird life, this time directly on Earth, only talking about Earth-like creatures. Actually, I think we might talk about aliens a little bit as well, but um, we're going to be reading that next month. So again, sciencefriday.com/book club is where you can find all the stuff about the upcoming months, as well as everything we talked about the possibility of life. We have discussion questions. We have all kinds of other stuff. And we're talking about the book together next week, just the community together. And so if you want to join it, that you can, again, our website is the best place to go. So thank you, Jamie.
Thank
Thank
you
you,
so much.
audience. And we will see you again all very soon. Have a lovely night.
Bye.
Bye, everyone. See you
Bye.
soon.